Good afternoon. We are Team 3A and we are excited to present our solution to Challenge 3. The purpose of the challenge is to process data and present Worley UK's Scope 3 emissions data to provide useful insights into the sources of these emissions, both by type of emission and geographic location. This has not only the potential to fulfill Worley's regulatory requirements, but also provide a tool to target Worley's efforts in reducing greenhouse gas emissions across the business.
Scope 3 emissions are a relatively new term used to classify indirect emissions associated with a company's activities. The UK has committed to reaching net zero emissions by 2050, which means it will soon require companies to report and mitigate all its emissions. For the purpose of this project, we have focused on emissions from business travel, employee commuting, work from home, and paper consumption. This project impacts 3 types of different users with different stories. For Worley management, it is a tool to get a comprehensive picture of the company's emissions in order to manage net zero expectations. For our sustainability champions, it will allow us for easier tracking and analysis when drafting environment mitigation roadmaps. And for our employees, it's a useful dashboard to understand their average contribution to CO2 emissions.
We broke the task down by data type and identified what work we would have to do for each. We thought that calculations would be better placed inside Power BI, so that should government guidance change, these calculations can be updated without having access to the Python codebase. We then brought together a mock dashboard that would allow us to focus our attention and assign the tasks to team members.
For business travel, the files are provided by the travel booking agents and are in various different languages and formats. We use Python together with Google Translate API to organize this data into a consistent format and provide consistent output files. These were then used by Power BI to produce the visuals. For the employee commuting working from home, we had a single import file with around 1,500 employee postcode and office postcode information. This also had the days in the office and the transport type. Again, we used Python, this time with the Google Distance Matrix API, to calculate distances for driving and public transport for each employee. This was then put into an output file with the employee postcode and office postcode trimmed to only give the city locator. Again, this was then imported into Power BI to do the calculation of the emissions and develop visuals. And finally, the paper consumption was already in a more or less usable Excel format, so there was little transformation to do other than bringing it into Power BI.
Now we'll talk you through our Power BI dashboard. The processed data from the different sources are all imported into the Power BI report, and in-app calculations are made to get the total emissions for each category. Our report contains 2 pages to showcase the data available at a global view, and then a more detailed view of the individual countries. The aim is for the key numbers to stand out and to allow our Scope 3 emissions to be visible and an equivalent term in terms of car travel or trees planted, so that it's easily understandable for employees and managers alike. The standout numbers are our total emissions, and there is more in-depth detail into some of the different categories in further visuals.
So what benefits does our solution provide to Worley? It provides insights and context for Scope 3 emissions, what is causing them and where they are occurring. This is the first step in developing strategies to reduce these emissions. It provides a reliable and repeatable way to process and present Scope 3 emissions data. The resulting data is provided with context to aid understanding of the impact of these emissions. By utilizing an in-house tool, data security is improved and costs are reduced when compared to using a third-party software.
Our biggest challenge was attaining complete and comprehensive data in a standardized format. However, as there's a push to collect this data, our next step is to push a global rollout with increased content. In addition to improved accessibility and usability, we will transport this dashboard into an all-inclusive app for employees and our management.
What impact does working from home have on a company's Scope 3 emissions? What are the contributing factors to these emissions? The pandemic and working from home have greatly reduced the need for business travel. Having proved work from home is possible, it is unlikely to return to previous levels, resulting in a permanent reduction. Where savings have been achieved on commuting, alongside the corresponding saving from office space reductions, these are unfortunately eroded by individual Scope 3 emissions increasing by a factor of 2. What additional functionality can you pull from the Google Maps API? How can you use this functionality in conjunction with data collection to measure Scope 3 emissions more accurately? In addition to the data already collected via the API, should individuals provide a more detailed breakdown of transit type, the API is capable of returning more accurate figures. Additionally, there may be the option of analysing the time and financial cost to individuals of migrating to a less carbon-intensive mode of travel. What is the future for Scope 3 emissions? What will companies need to consider and what will they need to know? At present, Scope 3 emissions reporting is a nice to have. However, with increasing focus on environmental protection, this is likely to become a legal requirement in the near future. Beyond the ethical requirement to reduce our emissions as a company, this is likely to be a factor that clients consider when awarding contracts. It is important to remember that there is a complex interrelationship between the emissions of companies and their various partners and stakeholders. It will therefore be important to have this data readily available for collaboration.